Hi everybody, and welcome to the beta release of Onyx version 0.1.9. This release brings some major syntax changes, including optional semicolons, and some better support for OVM-Wasm on macOS, and just a number of bug fixes throughout the entire compiler and standard library. I just want to talk about some of these changes in this video, just demo some of them just a little bit, but I should mention that if you want to get this newest version of Onyx, you can just go to the home page and rerun this same command. It will automatically pull the newest version of Onyx, which should be 0.1.9. I should also mention that Onyx does have nightly releases, and if you want to install one of those, you simply run, if I can find the right window, you simply run that command. I would recommend copying it instead of typing it out, but I've had to type it so many times I have it memorized. You simply run that command and then follow it up with the word nightly. This will simply allow you to download the nightly version of Onyx, which I release. Whenever I push a commit during the day, I'll release a nightly build before I go to bed. I just make sure that everything's working before I send it off for people to keep for a while. But the nightly builds are out there and relatively stable, but they are also nightly, so use them with caution. If I go back to these changes, let's just talk through some of them because some of them are pretty cool. So the big one, we have some major syntax changes, including the addition of two new keywords, and those are in and as. So these new keywords are here to clean up some old syntax that I never truly loved. I kind of took it from other languages, and then it just kind of stuck. But after talking to one of the community members, I thought it was worth changing the syntax, and I thought it would be best to do it now. Well, the community is relatively small, and the amount of Onyx code out there is still relatively small. And so this is what these changes are. Basically, for for loops now look like Odin's for loops or Python's for loops, however you want to think of them. Basically, you just replace that colon that used to be there. Right? If I were to open up an Onyx file, right? You take the colon that used to be there, right? It used to be like 4x colon 0 to 10, right? You take that colon and you just replace it with the word in. This seems like a really small change, but it does help the code read a little bit better, and for people more familiar with something like Python, it'll translate a little bit nicer. And even if you're more familiar with like JavaScript, it still translates nicely. The colon was a little weird, and as one of the community members pointed out, it was almost lying a little bit, because normally what follows a colon is a type. But in this syntax, what's following the colon is the value. My only slight justification for this was that before, you could just search for any symbol followed by a colon, and you will get all of the symbols that are declared in your file. But it doesn't really follow correctly here, right? If anything, what it should have been is something like this, which is really similar to what Go has. But I still don't like this because it's also lying to you, because normally what this operator means is the left-hand side becomes the same type as the right-hand side, but that's not what's happening in a for loop. In the for loop, the right-hand side is like the iterable, and then the for variable is just the iteration value, and so generally those are not the same type. In fact, I don't think they're ever the same type, and so because of that, I just decided to go with the in keyword. It's a new keyword. It's currently only used in this position, but that's not to say that we couldn't have more fun with it, creating something like Python's if x in an array kind of syntax. This is not in the language right now, but this would be really easy to add as just another binary operator with another operator overload. But the other advantage that this gives us is that we can now write our for loops in a little bit different way. And so what we can do is we can actually, if I take this example from the article, we can explicitly type both the value, like our iteration value, and this other thing that I didn't even mention, called the index. We can explicitly type these with whatever types we want. So to mention it now, this index is also something that we get with for loops now. You can have a second iteration value, just you put a comma and then another value, and this value is called the index. it is always set to 0 on the first iteration, and then always increments by 1. Currently, there is no way to change where it starts, and it's nothing that's controlled by the thing over here, right? It's just this counter that you get for free, right? It is basically equivalent to, if I were to write this in a different way, it'd be equivalent to writing this code with the defer index at equal to 1, right? Equivalent to this. But obviously this is a little bit nicer and just easier to read, I think, in general. So anyway, you get that index, which is nice. And here we can see we're explicitly typing these variables. So we're saying value here, we're expecting it to be a string. An index, we're saying, is a 32-bit integer. And so if I print these values out using maybe just a standard printf, and if I remember my key bindings, and I try to run this file is called demo. Right, I need a semicolon. For now, we'll talk about that. Oh, and then I also need to import the printf function. Cool, as you can see, we get a list of strings with all of their indices. So that's super convenient. I will say that this type here, this is the type of the iteration value. It is completely unnecessary because you literally cannot put anything else here. If I put a different type, I will get a compile time error saying that you specified that the type should be i32, but really it should be a slice of bytes, or also known as a string, because that's what you're iterating over. So this one is entirely optional. It's a little redundant, but if you need to help your code readability, it can significantly help. But this index one actually is rather useful to have, because by default it is an i32, and so we can run this code without any changes. But you can also make it a different value, like an i64, or heck, an i16, whatever you want. Any integer-like value can be used there, and you can, if it happens that it's nicer for you to be a u64, you can do that. So that's the new for loops, right? They use the in keyword now instead of the colon. You have this index thing that you get for free, and you can explicitly type both the index and the value, or if you just want them to be inferred, you can just write it in a really short way like this. Another thing that just changes syntax a little bit that is just kind of a nicety is the cases with captures. So before a case with a capture, if I create like some x that's like an optional i32, and I switch over x, right, the old syntax would have been something that looks like this, where it says capture value based on if it's a sum, and if it's a sum, then we get the value out. The problem with this is, again, it's that same what's over here is not a type, and then also I feel like this is backwards. Like, the sum should be the most important thing. That should be at the beginning of the line. The other detail about which value you're capturing, or the name of it that you're giving, that should be somewhere else. And so because of that, I opted to move this one as well. And so it moves to after the case, and then also it uses the as keyword to specify the value. And so, right, it looks just a little bit different. I think it reads a lot better. And the old syntax kind of looked good only because the for loops kind of looked like this, right? Like if you kind of think of this as like a for loop, kind of takes on the same shape. But I just think this is a lot harder to read and reason about. With this new syntax, I think it just reads a lot better. And also worth mentioning, you can still do the capture by pointer thing if you want to do that. So that's just a tiny little change, but when I changed for loops, I felt that I also had to change these, and so hopefully that's okay. Interfaces also got a little bit of a change, because while I was changing all the syntax, I'm like, well, interfaces, I haven't loved how they've looked for a while, and so I wanted to modify those as well. And so I figured the best time to do that would be right now, when I'm already changing a lot of other syntactic things. So if I just copy this example and we take a look at it, what interfaces used to look like, if I were to write the equivalent of what I have below, it used to look like this, which I did not like a lot because it's a little confusing what is being said here. So what this meant was that when you specify an interface constraint, you're going to give it a type, and then you're going to get a value of that type, in this case t, and that value you can use in the body as a stand-in for something of the type t, like something of type t. But I just didn't love that because it doesn't line up with like how you're calling it, and it's just, I don't know, it's not great. The new syntax is this. Interfaces now look a lot more like procedures or structures with parameters, where they just take in these type expressions like this. Note that this does open you up to being able to take in things that are not type expressions. If for some reason you want to take in some other compile time known thing as an argument, you can do that now, which is kind of sweet. But of course, this removes spelling out what the value of type t is in here, and so there's now this syntax using that as keyword that we added that says little t is something of type t. So it's a little, right, you could maybe say something like this, but this is a little confusing because, like, is this a variable that's accessible outside of this interface, or is this something only in this interface? I didn't like that as much, and so one of the community members said, oh, you could use the new as keyword, and I thought that was a really good idea. And so I went with that. And so this is even more powerful because you can say just t as t like this, or you could even say t as iterator of t, where t is now, like little t is now an iterator over t, and you can use little t as a stand-in for that. And of course, you could make any number of these things, right? I could have a little w is a slice of t's or whatever, right? However you want to write your interface, they're a lot more flexible now. And so I quite like this feature. So that's pretty sweet. And then the thing that I've kind of hinted at, optional semicolons. So this is a very experimental feature, but I have enjoyed using it in all the experiments that I've done. And so I just wanted to show you that it's included. Basically, the way to use optional semicolons, you can either pass a compile flag. So I'm just going to demonstrate this by printing working and printing, I'm just going to say printing add of 1 and 2, right? Just using these things. And I'm going to go through and I'm going to delete all of these semicolons. Okay, if I try to run this as is, I get expected token semicolon, got print line, of course, right? It wanted the semicolon here. I can simply pass this flag, -- feature space optional semicolons. I can pass that to the compiler, and I feel silly because it, did I misspell? Do I have, this is a debugging in video. Let me look for optional semicolons. Let me double check that feature optional semicolons. Let me double check a couple things. First off, which Onyx I'm using. The next off, which version. I don't know why I'm using that version. I'm going to build Onyx, and I'm going to build it using, this is embarrassing. So I'm going to compile and install. I don't know why that flag isn't working. That's honestly very confusing. Oh my gosh. Has it been saying, oh, I feel even sillier. Read your error messages, kids. So the actual error here is because I'm using printline and not printf. Read your actual error messages, kids. Okay. Wow, I might have to cut that. I might just leave it in because it's funny. Right, so the actual error was that I was using the wrong print function. I didn't have it imported. But as you can see, if I actually run this with feature optional semicolons, you'll see that this works now. Right, everywhere that there was a semicolon, I removed it. And now I could write all of my code without semicolons, right? Which is kind of cool, right? I can just print x to 10 and so on, right? It's great. So this is kind of a slightly big commitment, right? Switching to using optional semicolons across your entire project, right? That's what this feature flag does. And so if you just want to test it out file by file, right? Maybe you have just one file that you want to test this out on. You can instead, if I can go back to my terminal, you can instead pass, not really pass, you put optional semicolons with a dash. You put this as the first line, first token of your file, right? If you have a package declaration up here, it has to be before the package declaration. That's the very, very first thing in the file, because it's something that the lexer has to look at, so it has to occur very early on. And so you put this optional semicolons there, and now you'll see I can run this without passing optional semicolons, right? And it still works. No compile errors. Right? So if you want to try it out, you can do that on a per file basis, and it's super non-commitment to do. So the way that this works, just to briefly talk about it, it works in a very similar way to how Odin implemented these things, and Odin was inspired by a different language doing optional semicolons. The basic idea is that at the lexical analyzer level, basically when it's breaking all of the characters into tokens, whenever it encounters a new line token, it simply looks at the last token that it produced and sees if it's one of the following, and if it is, it simply then inserts a semicolon into the token stream. And then the parser will just see that semicolon. There's a little bit of extra logic about like what if the parser didn't want a semicolon there, but that's the basic idea. And so this is the full list of things that if they end the line, it's going to put a semicolon there. And so this does have some interesting connotations, right? If you're used to writing like, maybe you wouldn't quite write it like this, but 1 + 2 + 3, right? Like this used to work in Onyx, but if you try to run it now, you'll get unexpected tokens. In fact, I'm honestly surprised you get 2 of them. But if you put the plus at the end of the line and not at the beginning, then you can even get rid of that last semicolon and it will work. And that's because the plus is ending the line, and therefore that's not one of the tokens that inserts a semicolon. But before, the 1 was ending the line, and so that's where it stopped reading, and then these other 2 were just on separate instructions or separate statements. And so that's been a couple of the rough cases that I've had to manually go change things, is because I did write things. I had a tendency of writing like if condition and condition 2 and condition 3, right? Something like this, which of course has the same issue where the ands need to be at the end of the preceding line and not the start of the next line. So that's some of the rough cases that I've had to work through. But other than that, I'm really enjoying writing Onyx without semicolons. I've already gotten into the habit of not typing them. And so I do believe this will be the default in a future release, but I'll have to see what the community says. I think it'll be largely accepted. I'm indifferent on semicolons, but I have enjoyed writing it without them. Okay. One thing to mention, if you have written quite a bit of Onyx code, and you have some code that you want to move over to this new syntax, right? The 2 really big ones that might take a lot of effort to convert are all of your for loops and then your case statements, depending upon what kind of code you're writing. And so I have these rather scary find commands, these find sed commands, that I have tested, and they have worked on every project that I've thrown them at. They are something that you should be careful running, right? Make a backup. Maybe Git is a good enough backup, but honestly, a copy of the whole folder might not be a bad idea, because these are a little scary because these do replace, they replace in place. And so they will just modify the files as they are. Thinking about it now, if you're on macOS, you might have to separate this out and do, it'll look like sed tech r tech I, and then put a an ending here, something like backup or back or something like that, because on Mac, I don't think they let you just do in place sed stuff. You have to specify a backup file that's going to copy everything to, which sadly will litter your directory, but then you can run another command to remove all of those junk files after you know that everything's okay. And so that's just something you have to be aware of. But both of these commands, right, this one's converting the for loops, this one's converting the case statements. They worked for me in every case, and so hopefully that'll be all right. The interfaces, I don't think many people have really written interfaces, and if you have, they're not that much work to type out to change because you don't really write interfaces all that often. So that's all the syntax changes, at least all the ones that I can remember. They're pretty nice. I'm super excited to see what Onyx is going to look like. This is probably going to be the last round of big syntax changes for a little while. The next releases are mostly going to focus on more usability and kind of different environments that Onyx can play in, right? I'll talk about that a little bit later. So just to go on and hit these other bullet points, this is a big one. OVM-Wasm, which is Onyx's custom WebAssembly runtime, it now has support for macOS. And so this means that when you're installing Onyx and you have that choice of do you want WASM or OVM, you can choose OVM-Wasm from the installer now on macOS. And it also means that you can do debugging on macOS. And so basically you just have to have the OVM-Wasm version of Onyx installed, and then I only debug really through VS Code, so that's the one that I'm familiar with. If you have other like NeoVim's debug adapter protocol extension or other things, you could try to get that to work. I honestly have not given it much thought. I just use VS Code's. I turned off the server because I was updating something. I only use VS Code's extension to debug, so that's the way that I know that it works. But this is a really big one because now people on macOS are able to debug Onyx, which is super sweet. So give that a try. I'm sure it's not going to work for some people for some reason, but drop an issue in the GitLab or GitHub, and I'll be on trying to fix it. And that was also, I should mention, that was from community contributions. That was someone decided that they wanted to make it work, and so they spent a couple weeks on their Mac making it work, and for that I'm very thankful. It's very cool. The same person also wanted to add the basics of array programming. And so the basic idea of array programming is that for small arrays, you can treat them kind of like they're just values, kind of like SIMD things, if you're familiar with those. And so this is just a really simple example, but here I have a vector 2, which is simply just a fixed sized array of 2 I32s. And so I can declare that vector 2 on my stack. I can then use the X and Y accessors to set the first and second properties respectively. And so basically this is just synonymous with V sub 0, and then Y is synonymous with V sub 1, but this feels a lot more like you're writing actual vector stuff. And so this is super nice to use, and in the future it means that hopefully any library that wants to create like a vector type or a point type or whatever can just treat it as like a 2-component I32. So instead of having to deal with like your graphics library's vector type and your physics library's vector type, and maybe your internal graphics or like other UI vector type, they can all just be a 2-component I32, and then they all just work seamlessly with each other. So that's the goal, and this is super cool. Also worth mentioning that these do come with some nice operator overloads that are built in for things like multiplying by scalars, multiplying component-wise. So some of that is in there, and it is pretty sweet to see. So hopefully some cool programs come out of using that. All right, on to some miscellaneous improvements. The first one is tree shaking. So the basic idea with this was that Onyx was producing binaries that were rather large for what they were doing, and this was mostly due to just how little Onyx did to shake down the amount of code that it's putting in the binary. Just about anything that you wrote in code was getting put into the binary. Even if you were just calling printf to do a hello world, it was still putting in networking networking calls and other things, which is just unnecessary. And so Onyx now performs a simple tree shaking algorithm to search through what you're actually using and only put that stuff in the binary. It was honestly not that much code to write. It was only about, I'm going to guess, 50 to 100 line diff, if that. And basically it just only outputs the things that it knows for sure you're going to have to do. One caveat to this, to actually make this tree shaking effective, the methods field, which lives on the type info union and structures in the type info package, they are now left empty by default, right? There's no method specified by default. And that's because if we think about what a method really is, right? If I pull up the code for, so if I hop into the Onyx library, and if I pull up, so let's say the code for the networking, right? You have the socket, for example, which has all this information about what a socket is, but then you have all of these things, which are all methods, right? They're all the things that you can say socket, arrow, whatever, right? Instead of saying net.socket close of the socket, right? They're just conveniences, but all of these methods were being written into the binary. And so that meant that all of the functions that those would call would also be written into the binary, because in principle, you could go through the methods field to find the function, to call it dynamically, and so there was no way to prove that you weren't using it, at least not in a super simple way. And so it wasn't really, like, this tree shaking wasn't doing that much because there were still all of these methods. And so by default, they're now left out because you generally don't need them anyway. And so, yeah, that just helped the tree shaking actually do its job really well. If you do want these methods because you are using them for something, you simply have to pass the generate method info flag to the compiler when you're running or building your Onyx project. So it's a little annoying, but also I don't really use these. I see how they could be used, but they also are just a lot of bloat. So they're now behind a feature flag, which is perfectly fine. Another miscellaneous thing, kind of a syntax thing, and this is a thing that a lot of people don't even use, but it's something I was experimenting with. So Onyx does have the ability to do what's called a bottom test loop, which, if you're not familiar with that, it's where you basically have a while loop, except the condition is not checked until the end of the loop. So the loop is always going to go through at least one time, and then at the bottom is where you determine if you're going to jump back up, right? So in Lua, this is like the repeat until loop. In C, this is the do while loop, right? Do these things while this condition is true. Right? Just about every language has a form of the bottom test loop because they are super useful for certain algorithms where you know you're going to do something and then you just need to see if you need to do it again, right? Like try to write something, and if it fails, you need to do it again, right? That kind of code. So the old syntax, which still does work, is while bottom test, then the condition, right? And you just have this weird directive bottom test. It doesn't really make any sense, but like that's what it was. It was a hacky thing anyway. To make it feel a little bit more official and like it's an actual feature of the language, I added this thing called while defer. So defer basically meaning defer this condition check to the end of this block. It's not the exact same syntax as like C, but it's maybe closer to a good syntax for these. I'm still on the fence about it, but basically this is one case where it would actually matter, because here I is already equal to 10, and we're checking if I is less than 10 in this condition. And normally, if this was a normal while loop, we would not see anything printed at all. But because we're checking if I is less than 10 after we print, right? That's a deferred check. That tells us that it actually will print 10, and then it will exit after that. And so it's a small thing, but hey, it's there now. And that's it for all the notable features. I'm going to scroll through, see if there's anything else in here. Ooh, this was one that I didn't really mention because it's not super important, but there is also now a alternative syntax for dereferencing. So before, your syntax was basically, if I have x is like 5, and you said y is a pointer to x, before you'd have to say like print line star x, right? The issue with this is if you say had z that was a pointer to y, and so z is a double pointer, right? If I print line the type of z, it's going to be a pointer to a pointer of i32. Okay, and so if I want to change x using this z value, I would have to write star star z, which I don't even know if that actually is, that is valid syntax. Oh, I'm bad at coming up with examples, because this actually will work, right? This will print out 10. But let's just say there are some cases where you would be forced to put parentheses around this. Namely, if you were doing like a kind of subscript, or if you were doing a kind of like method or accessing a field off of this thing, right? You would have to wrap this dereference in parentheses, and that's just a little annoying, and it's a little bit of line noise that I don't think we need. And so as an alternative syntax, you can use dot star to mean dereference, but this is a postfix dereference, and so you don't need to wrap it in parentheses, because it's a little bit better. And so if you want to dereference twice, you can use this syntax, which I know looks a little bit weird, but it does work. And I actually did end up using this syntax in something because I was writing, I had a pointer to a hash map, and I wanted to say, basically look up the foo thing. But if I try to do this, what I'm going to get, right, if I try to print line this, I'm going to get a compile error basically saying that this isn't understood for a pointer to a map and a U30, a string. But if I surrounded this in print like this, this would obviously work. And of course, I'm going to get none there because we don't have any values in there. But I didn't like these extra parentheses, and so I was like, oh, I have the new syntax. I can write it like this, which I know looks a little weird still, but just experimenting with other syntax things, just seeing what looks good and what doesn't. Other things worth note, the where clauses, when you're doing interface constraints on procedures, they can now have any arbitrary Boolean expression. And so it doesn't have to be an interface constraint. It could just be constraining that some integer is less than a value, or maybe is equal to a value, or something like that. All right, we talked about the small arrays having accessors. We talked about wall defer. There's a number of additions to the standard library, just kind of all over. So removals, I used to ship all the test cases with the compiler, but I don't think anyone was using them. And if you want to look at test cases as examples, they're on the GitHub repository. So I'm not going to ship all that extra code when it's not used by anyone. We talked about the methods not being populated. Oh, this is a tiny one, but cpointer.as, because as is now a keyword, it had to be renamed. And so I guess I picked cname or cpointer.as_unsafe, which is fair because it is a rather unsafe operation. If you're using as unsafe, you should know what you're doing. And then there's just a whole bunch of bug fixes, because I kind of forget that there hasn't been a new release of Onyx since December, well, really like December 1st, basically. I think it was actually technically November 28th. And And so it's been a while. I've been releasing things on nightly, but there's been a lot of bug fixes since November, and so definitely update to get rid of all of those bugs. Better error reporting all over, fixed implementations of a lot of functions. I'm only mentioning this one because I think this one was rather egregious. I forget how bad it was, but there's just been a lot of fixes. And then finally, just special thanks to all these people for contributing. It really means a lot that people are putting time into this project as well as me. And so I'm going to do my best. I suspect we might have even more contributors in the future, but any contributors are going to get a call out in every release for how many pull requests they had since the last release. So just a special thanks to those people. And with that, I believe that is everything that's new in the beta release. Let me know if there's any deeply concerning things, and we can maybe publish out a hot fix. But I think it's in a good state, and I'm really liking how Onyx feels to write now with the new syntax and the optional semicolons and all of those other things. So go download it, try it out. Let me know if there's anything major that needs to be improved. Otherwise, have fun writing Onyx.